All right, so in this video, we are going to talk about what happens when we are dividing polynomials, and we're going to divide using long division. So before we do that, let's remember how to actually do long division. So this number, if you're given a statement like this number in the bottom is your divisor. So that's the thing that I'm dividing into the number on top. You could also see it written like this. Those are equivalent statements. Either way, you slice it or dice it. We're going to set up our long division this way. So the first thing I need to think about is how many times 18 could go into 59. Well, 2 18s is 36. So 3 18s would give me 54, and that's as close as I'm going to get. So I am going to put 3 as my value for the tens place. I'm going to multiply 3 by 18, gives me 54. I'm going to subtract that. That would leave me 5 left over. And oh, look, it's 54. Well, I just figured out that 18 goes into 54 3 times. So my remainder here would be 0. So 18 divided into 594 gives me 33. We can do the same thing with the next one. I'm dividing 44 into 902. So 2 44s gives me 88. That's as close as I can get to 90. So 2 times 44 gives me 88. Subtracting that gives me 2. So I'm actually not going to be able to divide 44 into 22. So I'm going to have to put a 0 here because that didn't work. And remember, I can continue adding decimals at the end here. So 2 44s gave me 88. 3 44s gives me 132. 4 44s gives me 176. 5 44s gives me 220. So that's going to be a 5 there. Remember, I have to put the decimal point there because I am now going into the decimals. So this is the tenths place. So that would be 220. I'm going to subtract. So you could write this as 20.5 or 20 1/2. So that's doing long division just with numbers, just as a little reminder. But we have to now apply this to polynomials. So I still have a divisor here. Now this is a polynomial divided by a monomial. So if there is only one term in your denominator, and you are dividing by a monomial. This is a special case where I can split each of these into separate fractions because I can divide 6x evenly into each of these terms. So really what I'm thinking is 18x to the fourth divided by 6x minus 24x cubed divided by 6x minus 6x squared divided by 6x plus 12x divided by 6x. So now I have 4 different fractions to represent the 4 different terms that I had in the numerator. And now I'm going to simplify each of these fractions. Well, 6 goes into 18 3 times. And x, remember our exponent rules, x to the fourth and x in the numerator, or excuse me, x to the fourth in the numerator and x in the denominator. Technically, this has an exponent of 1. And when I have the same variable in the numerator and the denominator, my exponents subtract. So that's going to leave me with x cubed minus 6 into 24 goes 4 times. Subtracting 1 from my x cubed gives me x squared. 6 divided by 6 gives me 1. So technically there will be a 1 here. We know we don't have to write a coefficient of 1. And then x squared divided by x leaves me with just x. 6 into 12 is 2. And then x divided by x, that's going to just leave me with 1. I do not need to write 2 times 1. And that would be my final answer. Now, those are special cases. Remember, that's if there's only one term or a monomial in the denominator. That will not always be the case, because I could have questions like this. Now, this is where we have to use what we know about long division to move forward. So we're going to do this problem together. I'm going to then give you the steps, and then we'll do some more examples together. So x plus 2 is my divisor. That's going to go on the outside. And then I'm going to have x squared minus 3x minus 10. One thing to notice here is that I do have my x squared term, I have an x term, and I have a constant. We need to make sure that I am including the exponents in descending order, so it needs to be in standard form. And I need to make sure that all of my terms for each exponent are included. So the highest exponent is 2, so I need to see an exponent of 2, an exponent of 1, and then my constant. So we're going to do the same process we did with long division, but now I'm just doing it with variables. So x times what gives me x squared? Well, that would be an x. So I'm going to have x times x giving me x squared, and I'm going to have x times 2 giving me 2x. And technically, if we're going to be all specific about it, that should go over the x's and not the x squareds. All right, now I'm going to subtract. So I have negative 3x minus 2x giving me negative 5x, and I'm going to bring down the minus 10. So x times what gives me negative 5x? Well, that would be minus 5. So negative 5 times x gives me negative 5x. Negative 5 times 2 gives me negative 10. I am subtracting these negatives, which is going to then turn into a plus, and it's going to leave me with a remainder of 0. So what this tells me, since this is a remainder of 0, is that x plus 2 and x minus 5 are factors of x squared minus 3x minus 10. So there's a couple ways that we could write our answer. You might see it like this. You could also rewrite this in its factored form. So you could write that x squared minus 3x minus 10 is x plus 2 times x minus 5. But typically, if you see this as your question, your answer would just be written as the one factor that's your answer when you divide. But know that these two things are equivalent statements. So what we just did are these steps. It's the same steps that we do when we're dividing numbers using long division. The only difference is now it has exponents. All right, so let's do this one. So we got x plus 4 here. Got 2x cubed plus 8x squared minus 3x minus 12. Looking quick inspection-wise, I have 3, 2, 1, and constant for my exponents. So x times what is going to get me 2x cubed? Well, I need a 2, and I need an x squared. Multiplying through, 2x squared times x gives me 2x cubed. 2x squared times 4 gives me 8x squared. Well, now I'm subtracting these. That's going to leave me with 0. So my next term is going to be negative 3x minus 12. So technically, you could put a plus 0 here, but that's not really going to be super beneficial for us in the long run because I'm not going to see a plus 0x in my answer. So x times what gives me negative 3x? Well, that would be negative 3. So negative 3 times x gives me negative 3x. Negative 3 times 4 gives me negative 12. And remember, I'm subtracting negatives, so that turns out to be plus. And I have a remainder of 0. And again, since I have a remainder of 0, that tells me that 2x squared minus 3 and x plus 4 are factors of my original polynomial. All right, so those were dividing if we did not have a remainder. What's going to be different if we do have a remainder? So let's go ahead and start with our division. So x into x squared, I need an x. So x times x gives me x squared. X times negative 2 gives me negative 2x. I'm subtracting these, so I'm doing the opposite sign. This gives me 4x minus 7. So in order to get to 4x, I need to multiply by a positive 4. 4 times x gives me 4x. 4 times negative 2 gives me negative 8. I'm doing the opposite, so I'm subtracting and adding. So this is going to give me 1. This is a remainder. It's not 0. So technically, now when we were in elementary school, we would write remainder 1. But we're not in elementary school anymore. So we have to know how to write this remainder if I'm dealing with it as a polynomial. Technically, our remainder is a fraction using our divisor. So if we were going to write our answer, it would be x plus 4, which is what we got when we did our division, plus whatever our remainder was, divided by our divisor. So this is the only difference if I have a remainder. So in this case, x minus 2 and x plus 4 are not fractions because they do not evenly divide and I have a remainder. I mean, not fractions. They're not factors because I have a leftover. I have a remainder at the end. So let's do 2 more of this with remainders. So doing a quick inspection again, 3, 2, 1 constant. I'm good with all of my places. So I'm going to have x plus 2, x cubed minus 4x squared plus 2x minus 3. So here, to get to x cubed, I need to multiply by x squared. It's going to give me x cubed. X squared times 2 gives me 2x squared. Subtracting gives me negative 6x squared So now in order to get to negative 6x squared, I need negative 6x. And I'm going to multiply that through by both terms here. Subtracting, so I'm doing the opposite. So that's going to give me 14x minus 3. So I need to multiply by 14 here. And I'm going to do the opposite. So I need to subtract. So this is going to give me negative 31. So when I write my answer, it will be x squared minus 6x plus 14. Now in this case it's minus because my remainder was negative 31 over x plus 2. Let's do one more. Now doing a quick inspection here, I'm noticing I don't have all of my exponents, so I know I have to leave myself a space and include 0x squared. So to get to x cubed, I need x squared. Multiplying x squared into both of these is going to give me x cubed plus 2x squared. Doing the opposite means I'm subtracting. So I'm going to have negative 2x squared as my next term that I'm dividing into. So I'm going to need negative 2x in order to multiply my first term and get negative 2x squared. So multiplying through with negative 2x. Doing the opposite, so this is going to give me 5x. So I would be multiplying by 5 in this case to get 5x. And now doing the opposite is going to leave me a remainder of negative 12. So my answer here will be written as x squared minus 2x plus 5 minus, because my remainder was negative, 12 over x plus 2.